Okay, do you guys remember that? Now, this electron apartment building, this electron apartment building is going to be our quantum model of the atom. And we're going to liken that to the electron apartment building, okay? All right, now, remember we said first floor, second floor, on up. Okay, this apartment building can go to infinity, floor 1 to infinity. Okay, but by the 7th floor, we've run out of electrons. There just aren't any more elements that have more than that. And of the first 4 floors, that's where the majority of the electrons are. So we'll spend our time talking about the first 4. It does go to 7, and then it can go to infinity. We just haven't got there yet. So, do you remember on the first floor, how many apartments did we say on the first floor? 1. Second floor? 2. Third floor? 4th floor? 5th floor? 5, and so on, right? Now, do you remember what those apartments were? On the first floor, what was the apartment called? S. Second floor? S and P. Very good. Third floor has S, P, D, and the 4th floor, S, P, D, F. Let's just do the 5th floor for fun. What would that be? S, P, D, F, G. Oh, you guys are so awesome! Very good. Now, do you remember when we're looking for apartments, you talked about, cost and space. Well, what's the difference between those apartments? Well, the S apartment is very small. It's a little bitty apartment. It's only got 1 bedroom. Okay, the P apartment is going to be a little bit more expensive because it's bigger. And it's got 3 bedrooms. Okay, now, what do we say? S, P, and then D. Well, what about the D apartment? Well, it's even bigger still. And it's going to have 5 bedrooms. Okay, now we're getting pretty big. 5 bedrooms. Woo! All right, and then the F apartment. Wow, that's a penthouse. Exactly. That's got 7 rooms. You should see the theater room in that place. Oh, it's amazing. All right, so now, where do we usually find penthouses? Is that on the first floor? No, it's on the top floor. Oh, so where do you find the F apartment? Which floor do you find that? The 4th floor, right? Because it's not on the first floor. It's not on the 2nd. It's not on the 3rd. When we get to F, it's going to be on the 4th floor. That would make sense, right? Penthouse, higher up. Okay, so if I were to walk down the hallway on the first floor, you know how you have a door, and on the door is the apartment number? So it's the first floor, and there's only 1 apartment. You already told me that was the S apartment, right? So on that door is going to be apartment 1S. Okay, so if you open that door to apartment 1S, there's going to be 1 bedroom in there. All right, so that's the first floor. So let's run up to the 2nd floor. Go up the stairs. Okay, going down the hallway on the 2nd floor, what apartment numbers can I knock on? This is the 2nd floor, so this is 2S, right? 2S, and then I'm going to walk down the hall, and I'm going to hit 2P. And if I were to open that door into 2P, how many bedrooms would you see? 3 bedrooms, right, exactly. Okay, well, let's run up to the 3rd floor. Now let's knock on the door. What's the first door I'm going to knock on? 3S. Okay, 3S, very good. And then 3P, and then 3D. And if I open the 3D door, how many bedrooms am I going to see in there? 5. Remember, D has 5. Right? Does everybody remember that? D has 5. Okay, so I'm going to run up to the next floor. And this is the 4th floor. So the first apartment door I'm going to knock on would be 4S, then 4P, 4D, 4F. Exactly. Okay, and if you open the F apartment up, how many bedrooms? Wow, 7. This is like penthouse, right? Woo, it's really luxurious in there. Okay, that is the quantum model. That's where all the electrons go, and that's where they go. Now, in each bedroom, we can put 2 electrons max, and that's how the electrons are arranged in an atom. There's the model. Done. Everybody make sense? Everybody got that? Okay, awesome. Well, now we want to get mail. So if you're an electron and you're living in this electron apartment building, you want to get mail coming to you. Slow mail, right? Not email. So you want to get mail. You want to have an address where you could get things sent to you. So what's the address? We got to think of an address. We're going to use 4 numbers to describe every single electron in that apartment building. It's going to have its own unique 4-number address. So how are we going to do that? Well, let's start with our first floor. Okay, so these are going to be our 4 quantum numbers is what we're going to talk about. 4 quantum numbers. So now let's take that address, that 4 quantum numbers, and let's tie it to our apartment building. So the first floor, we said, oh, that was the floor. Okay, now I'm going to talk about a name that goes with that and a symbol. So the name we're going to give that is the shell. So if I say, hey, the first floor, that would be shell 1. Second floor, shell 2. Third floor, shell 3. Okay, it's going to be shell. Now it also has a name. It's called the principal. Since we're talking about quantum numbers, principal quantum number. Principal quantum number. So if I think principal quantum number, I'm talking about the first shell or the first floor. Does that make sense? Second floor, second shell. Okay, we're all talking about the floors. That's the principal quantum number. And I'm going to designate that as an N. Now, all those things, principal quantum number, floor, shell, and N, all mean the same thing. So you have to remember all of those. Because sometimes I'll say principal quantum number. Sometimes I'll say shell. Sometimes we'll say N. Okay, it all means the same thing. All right, so we said that there's floor 1, floor 2, floor 3, and then we'll go as far as fourth floor. Okay, now that's quantum number 1. Now, remember we said, oh, we're talking about the apartments? All right, so another word for apartment, this is our apartment, is going to be subshell. We're going to say subshell, meaning the apartment. And we're going to indicate that as the angular quantum number. And we're going to designate that as L. L for angular. That's L. So subshell, apartment, angular quantum number, L, they all mean the same thing. Now let's talk about that again. On the first floor, what's the apartment that you have? S. Okay, what's the second floor? What do you have? S. P. What's on the third floor? S. P. D. What's on the fourth floor? SPDF. There you go. Okay, that's the second quantum number. That's called the angular quantum number, right? Designation of L. Oh, but wait, these are not numbers. These are letters. Well, let's change them to numbers. All right. Well, an S apartment is going to be our, we're going to indicate that as 0. Okay, so every time you have S, we're going to think 0. Now, this S then is going to be 0, and then this is going to be 1, and then you count from there. So if we have our S, P, D, F. Now, didn't we sort of talk about these S, spherical, S, P, D, F? You remember those shapes? Okay. So the S was spherical, wasn't it? And that looks like a big circle, doesn't it? So we're going to call that 0. And then we're going to just number this. 1, 2, 3. Now don't confuse this number with the number of bedrooms that's in here. Because the S has 1 bedroom. It still has 1 bedroom. Instead of calling it the 1S, we're going to call it the 10. And then this P has how many bedrooms? 3. So instead of saying 2P, I'm going to say 21. So on the door, instead of 2P, it's going to be 21. Okay, apartment 21. So 21 is going to have 3 bedrooms. And then D, how many bedrooms does D have? 5. Okay, so instead of saying 3D, I'm going to say 32. Does that make sense? Okay, and then this one, F, has how many bedrooms? 7. And that apartment, instead of being the 4F apartment, it's going to be the what? 4-3 apartment. Does that make sense? All right, so that's our second quantum number. So let's go through and give these all a number. So S, what did we say S was? 0. P was 1. D is 2. Okay, here we go again. S is 0. P is 1. D is, F is 3. 3. Yeah, very good. Okay, perfect. That's the second quantum number. Ooh, we're almost there. This is the third quantum number. All right, our third quantum number was, hey, the bedrooms. So these are the bedrooms, and we're going to call those orbitals. Okay, these are the orbitals. Okay, and this is the magnetic quantum number. So if I say magnetic quantum number, I'm talking about the orbitals, which is the same thing as the bedrooms. They all mean the same thing. And M sub L is the symbol that we're going to give that. Now, as we talk about these bedrooms, let's talk about P bedrooms. There are 3 P bedrooms. Now, do you remember we talked about the shapes? We said, oh, P orbital. How many P orbitals were there? The other day, do you remember P orbitals? Yeah, there were 3. What was the shape of the P orbital? No, P.
On the windmill.
Yeah, the propeller. P for propeller, right? Wasn't that propeller shape?
Yeah.
Okay, and how many propeller shapes were there? 3. Now, what were the shapes of the D orbitals? Do you remember? Donut and double propeller. Remember that? There were 5 of them. Okay. All right. And then, do you remember the F? What was the F shape? Flower. And how many were there? 7. That's what we're talking about, is these orbitals. That's talking about the orbitals. And the S orbital, there was 1. And what was the shape of the S orbital? A sphere. Very good. All right. So propeller shape. There were 3 propeller shapes. That's what we're referring to with the 3 bedrooms. These are the orbitals. That's how many of those areas of probability. These are the orbitals, the areas of probability that we already talked about. All right. Well, those P orbitals, didn't they have direction? Yeah, do you remember the 3 directions? What? X, Y, Z. Okay, so remember those 3 directions? Okay, that's like saying when you're talking about these orbitals, we have to specify, well, which direction are we talking about? Which one are we talking about? So that's what we're going to give each of those directions a number, another number. Okay, that's what we're going to do. That's like saying when you go in to rent the apartment and you're like, hey, there's 3 bedrooms. Well, these 3 bedrooms have different orientations in space. Maybe I'm a morning person and I like the bright light coming in, so I'll take the east-facing bedroom. Maybe you're like to sleep in. You're like, I'm not taking the east one. I'm taking the west, where the sun doesn't come in the morning. So it's like that. There are different orientations in space. So these orbitals have different orientations in space. So we need to specify that. So how are we going to give a number to go with each of those orientations in space? Well, the way we're going to do it is we're going to say whatever L is, it's going to go from minus L to 0 to positive L. That'll help us come up with those numbers. So if S is 0, L is 0, then minus 0 to 0 to 0, that's still 0, right? And how many bedrooms are there in the S1? The S orbital is just 1. So we're going to call that 0. Now, in the P orbital, we said there are 3. So let's come up with those 3 numbers. Okay, here's another 0, so we'll go 0. Yep, already you're right there. Negative 1 to 0, positive 1. Those are the 3 numbers. Okay, so if P is 1, that's a negative 1, 0, positive 1. That's how I came up with those 3 numbers to talk about those 3 propeller shapes. Okay, so here we go again. Here is the S orbital. What am I going to call that? 0. Here's the P. I got 3 propeller shapes. Negative 1, 0, positive 1. Okay, now comes the D. Okay, here we go. Negative 2, negative 1, 0, positive 1, positive 2. How many D orbitals were there? 5. Did you give me 5 numbers? Check it out. I got all 5? Okay, good. All right, let's go again. S, what would that be? 0. What's P? Negative 1, 0, positive 1. Okay, what's D? Negative 2, negative 1, 0, positive 1, positive 2. Okay, now what's F? Negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3. How many of them were there in the F7? Did you give me 7 numbers? Oh, yeah, it works. Okay, that's the third quantum number. Okay, question?
The negative 3 is the L.
Yes, because there were 7 flower shapes.
And negative 2, where we got the
So,
D.
no, all these came from here, 3. So you count down whole numbers, negative 3, negative 2, negative 1, till you get to 0, and then you keep counting 1, 2, 3. Okay, so you go by whole numbers. You see that pattern?
Yeah.
Okay, does everybody make sense?
Just going down to make it positive on the other side.
Right, and you got to keep going till you get to 3.
Yeah.
That's how we got those.
Okay.
All right, so these are 3 quantum numbers. Now, what's the 4th quantum number? Well, that's our little person, or that's what we were calling the electron. This is the 4th quantum number. This is the spin quantum number. Okay, spin quantum number, M with a little sub s, spin quantum number. Now, there's only 2 numbers. There's a positive 1/2 and a negative 1/2, and that's it. So, just like there's guys and girls, it's positive 1/2, negative 1/2, and those are your 4 quantum numbers. So, if I have an electron living in this bedroom right here, can you specify that by its mailing address? Yeah, it would be this case. So this bedroom right here. So that was what? Let's kind of separate these a little bit here. All right, so if electron is living right here in this bedroom, what floor did we see it on? 3. What apartment? D, which is 2, and the bedroom is 2. So it's 3, 2, 2. That's where it lives. Okay? All right, so let's pick another electron. Let's see where this one would live. What do you want to pick? This one?
Yeah.
Okay, where does this one live? 2, 1, negative 1. Well, how about this electron? What would that be if it lived here? 2, 1, 0. Okay? So those are the numbers that specify every single electron in the atom. And we either have a positive 1/2 or negative 1/2, which refers to the spin. Okay, so here's our apartment building that we were talking about. On the first floor, if I had an electron that living right here in this bedroom, then I would specify that as 1, 0, 0, right? Okay, well, which other one do you want to, where do you else? The last one? This one? Yeah, which bedroom do you like?
1.
Okay, we'll do 1 and negative 2. All right, so let's do 1. If this electron is living right here in this apartment, this is the 3D apartment, then what would be its numbers? 3, 2, 1. Perfect. Well, what if it was living in this one? It would be 3, 2, negative 2. Perfect. You see how that works? Okay, so here's our apartments. Here's your bedrooms inside, and you would specify the numbers that go with that electron. Okay, can we do that? Yeah, awesome. Perfect. Okay, this is the table that we just created by thinking about this. So be able to create that, I think, would be the easiest thing to do. So on your scratch paper, when you first go in, take your exam, I would suggest that you recreate that table, which is the one we just did on the board. We just did that one. Caitlin.
I just wanted to ask you again, could you just go over what you just said with the apartments one more time? Because it just was a little too fast for me.
Okay. What apartment are you wanting to?
Giving the example of how you got that.
This one?
Yeah. You're saying negative 2, it would be.
This is the negative 2 bedroom.
Okay.
Well, what apartment are you in?
The D.
Yeah.
Okay.
And what do we call D?
The 2.
2. And what floor are you on? Third. Look, right here, 3rd floor. Is this the 3rd floor? We got 3 apartments. It's the 3rd floor.
Okay.
This is the 3rd floor. So it's 3. It's the apartment D. So that's 2. and it's the bedroom -2. Yeah? Okay. So once we have that, we can answer such questions as, is this a true set of quantum numbers? Okay, I'm going to put it up here, and you tell me if you think that's right. We'll say 3, 0, -2. No, what's wrong? There's no such thing as a -2 if you're a 0, right? Okay, let's go again. Let's say 2, 1, 0. Yes? All right, let's go again. 3, 3. No, you're already like, no. Okay, very good. All right, let's go again. 1, 0, 0. Yes. Okay, very good. Excellent. Do you see how that works? Yeah, so you'll be able to look here and decide, hey, which one of those is a true quantum number and which one of those are not correct.
So I'm sorry, the order of all this is going to go, it's going to go L.
It's going to go in this order. First quantum number, second quantum number, third order quantum number. It's always going to go in that order, right? Okay. All right. Make sense? Everybody can do that?
That chart is not going to be given.
Correct. That's what you got to know. That's no. I'm not giving you that one. You got to know that one. All right. Well, we talked about the spin quantum number. We said 1/2 and -1/2. I know we've talked about electrons can be a wave, or they can still act like a particle. So if we're talking about a particle, we can say that it has a spin. It's spinning. So when you have a charge that's spinning, it generates a magnetic field. So the direction of the north and south poles of a magnetic field are pointing this way. So this is north, that's south. We point in the direction of north, and we're spinning. Okay, well, we can have, what if the electron is flipped the other way? We can have the opposite spin. Yeah, you either spin clockwise or counterclockwise. So one way gives us this direction, north, and the other direction, we flip it over. The north now points down. So this is a +1/2, -1/2 spin. It doesn't really matter which one is clockwise or counterclockwise, which one we say positive or negative to. We're just going to say +1/2 is spin in one direction, -1/2 is spin in the other direction. And we're going to indicate that with an arrow. We can say up arrow, talking about the north and south, or we can say a down arrow. So this is another way that we can represent the electrons, is an up arrow or a down arrow. Okay, so that's a way that we can represent these electrons. All right, well, how does all this relate to Bohr's model? This was Bohr's model, where we had shell 1, shell 2, shell 3, those quantized levels. That's as far as he got, was the shell 1, shell 2, and shell 3. Okay, but we can go a little bit more. We can start talking about the energy associated with these. Bohr said, hey, you've got energy levels. That's a good start. But this is how it looks with the energy. Now, let's liken back to our apartment building. We said, oh, the bigger the apartment, isn't it going to be more expensive? So we can think of that as energy. So this is the first one. It's on the first floor. It's a really small apartment. Okay, it's pretty cheap. Yeah, no, not much energy. Very low energy. Okay, now when you go to the 2S apartment, that's on the second floor, it's still a one-bedroom, but it's more expensive because it's a little bigger. It's a little nicer. It's still a one-bedroom, but it's a little nicer. Yeah, it's a little upgraded. So it's got a little bit more energy. Then you go to the 2P, well, that would be more expensive, right, because it's bigger? Yeah, okay. And then 3S is, ooh, we're even nicer. More upgraded, a little bigger space, still one bedroom, but maybe we're talking, oh, marble countertops instead of linoleum, you know, some upgrades going here. And then 3P, and then 4S, 3D, 4P. Now it starts to get a little difficult with the energy, because you got 4S, but then you got a 3D stuck between the 4S and the 4P. So we're like, how are we going to know about this order of energy? We do have to know the order of energy. Okay, and we'll talk about ways that can help us remember this order of energy. All right, so here's a bigger list showing you the orders of energy. And as you can see, it starts to get a little bit more difficult following that order of energy the further up we go. All right, so we'll talk about that and how we're going to remember. But let's go back to this again. Here's our 1s. So let's just review again what those quantum numbers would be. 1, 0, 0, which we already did that one. Now here, 2s, this is a little bit higher energy, and so the quantum numbers again would be what? 2, 0, 0. Okay, exactly. That's the second one, a little bit higher energy. And then we go a little bit higher energy still. Now, look at these three orbitals. We can represent an orbital or a bedroom by a circle. You can also represent it by a box. If you were to draw the picture, you could draw boxes, or you could draw circles. This one we've got circles. Now the P apartment, we said, oh, has 3 bedrooms. Didn't we say that? 3 orbitals? Okay, here they are. They're represented by little circles, 3 of them. They're all attached together because they're in the same apartment. So they're going to have the same price. One of these bedrooms is not more expensive than the other one, is it? They're all attached together on this line, so they have the same energy. So there's a word that we use to describe that, and that's called degenerate. So we need to make sure we understand that word, degenerate. That's D-E-G-E-N-E-R-A-T-E. Degenerate. What does degenerate mean? Means same. What do we say? Degenerate meant same energy. Okay, so same energy means what? Degenerate. Okay, has everybody got that? If you have the same energy, that means you are degenerate. Degenerate means same energy. So let's talk about this. This orbital is degenerate with that orbital. Because aren't these the same energy? All right, this orbital is degenerate with that one. Same energy. How about this orbital and this orbital? Are they degenerate? No. 1s is never going to be degenerate with the 2p. Okay, how about, let's do p's. How about a 2p and a 3p? They're both p's. No, they're not degenerate because they're on different levels. Does that make sense? All right, so you know how to describe degenerate orbitals and which orbitals are degenerate. Another way to look at this is if you were looking at degenerate orbitals, these 3 are degenerate orbitals, which quantum numbers are going to be the same? The shell and the subshell. That's another clue. Shell and subshell will be the same if it's a degenerate orbitals. Now let's take a look at this one. Are the shell and subshell the same? No, so these are not degenerate. How about this one? Are the shell and subshell the same? No, so they're not degenerate. That's another way to look at that. Okay, so let's just practice pinpointing the male going to these electrons. Okay, so I want you to do the 6s and 4p. So what I want you to do is tell me the 6s and the 4p, what those quantum numbers are. Question?
Yes, about the orbitals, how do you, like, do we have to put them in order, like 1, 0, -1? Or
No.
We can just
No.
randomize?
Right, totally.
For the apartment 2s and 2p, that means they have the same energy. They don't have the same energy.
No, they do not. They do not have the same energy. A 2s is not the same energy as a 2p.
So they're on the same floor.
Yes, they're the same floor, but they're not the same energy. No, because the S apartment is small and the P is bigger. Even though they're the same floor, they're you're not going to be able to pay the same rent, right? Does that make sense? One's going to be a nicer place, so it's going to be more expensive, even though they're on the same floor. Okay? All right, good. Okay, so practice writing those numbers. I want you to tell me what are the quantum numbers that go with an electron if that electron was, what did we say, 6s? So there's 3 quantum numbers that go with that. And let's do 4p. So do them all for 4p. So for each bedroom, I want you to fill it in. And we'll say the 4th quantum number is a positive 1/2 for all of these, okay? We'll just say these are all positive 1/2. That's our 4th quantum number. It doesn't matter. We could have picked negative 1/2. Okay, so see if you can do that. And then make sure you touch base with your neighbor to see if you've got this down, if you understand this apartment building and how to specify the electron. Okay, and you can just write the three numbers right here, separating them all by a comma. Just write them like that. I like it. You look spiffy today.
I have to go to work after.
Oh, where do you work?
I work at CVS Pharmacy as a pharmacy technician.
Oh, that's right. Okay.
Trying to get some pharmacy experience.
Well, good.
Pharmacy school next year.
Okay, good. Very good. All right.
Very busy.
Yeah. You're doing great on your homework. Your attendance is excellent. So,
I
good
try
job.
not to try to keep school and work separated now.
All right. Well, good.
I did okay on the last test, just some problems. I was just like, I think towards the end of the test, I like freak out.
Oh, yeah.
I think I did fine at 86. So it's not bad.
Well, there you go. Good.
The next test, I want to get A for sure.
All right. That's this one that we're doing.
It's not as bad. It's not any like math or anything. So just
Yeah.
the first two tests, I was just like, oh my god, is Chem 2 gonna be like all math? Okay.
What Chem 2 is it picks up more details. Like we said, oh, we learned the first definition of an acid. You're going to learn the other two later. Or first law of thermodynamics, we're going to learn the other two later. So, hey, we talked about redox. Well, let's talk about it again a little bit more in depth. So it's more of what you have learned. Just we're going to add to it.
Yeah, and like application stuff.
Yes. So some students like it better because it's more arced in application, but it is more math.
There was one homework question I did not understand at all. I forgot which one it was. I did the extra credit to make
Oh,
up for
good.
it.
Oh, good.
But that one problem I cannot understand it. Like I sat there for like an hour and then I got my cousin to help me. She couldn't figure it out. So
Really?
she's like a med school student, you know. She was like, you need to go to the learning center and ask or something.
Yeah. Go to the learning center or shoot me an email or something. And
Yeah, I think I'll just screenshot your question or something because I have no idea how to do it.
okay. Yeah. Well, let's get that cleared up. Okay. Well, good. Good work. Hey, how are you? Good. 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 You getting it okay? You only did one of them. You got to do all 3 bedrooms. You only did 1 bedroom. You did the first bedroom. That's good, but what about the other 2? Okay, how are we doing? Okay? Okay, yeah, that is right. Yeah, good. That was easy, right? Yeah, so easy. Good job. You doing okay? Yeah, you are. 600, 1/2, perfect. 4, 1, yeah, keep going. Okay. Well, because there are 3 bedrooms. You just did an electron living here. Well, that's fine, but do the electron living here. And then do another electron living here. Yeah, so do them all. You're doing the 6S. That's all the way up at the top. 6.
Right here, right?
6S, way up there. Okay, so the first number is 6, because it's on the 6th floor.
Right.
If you pick 2,
No, that's not.
okay, all right, yeah. So 6S, that's the first number, 6. What's the S is always, no, S is always a 0. And then the orbital is always 0. S is always 0, the orbital is always 0. So 6s means 6, 0, 0. No, there is no other thing. There's only that one. That's it. Well, now do another example where the electron is right here. Give me those numbers where the electron is right there. Yeah? 4. No, S is 0. This is a P.
So 4 and then
1.
1. And then
Yeah, that's fine. Because if P is 1, then you have these three numbers. So this is one orbital, this is another orbital, and this is another. You did the 0 orbital, that's fine. Now do the other two orbitals. Yeah? Okay. You got it okay? All right, make sure you people around you get it as well. Okay, good. How about you guys? You doing it okay? Got it?
Question.
Okay, for 6s,
With 6, right? And it-
yeah, that's you said n is 1, so that means you're talking about the 1s. That is not the one we want. We wanted the 6s. Yes, because that is the floor. If I'm talking about the 6th floor, you can't send mail to the 1st floor. That's not the right place. You have to go to the 6th floor. If I say 6th floor, we got to go to the 6th floor. Yeah? So that's got to be a 6. Yeah, you got it okay? Perfect. All right, awesome. So everybody around you got that? Okay, great. Great. Okay, so you guys all getting it? Explain it. If you have trouble, explain that. Got it? Easy, right? You're like, this is so easy.
Yeah, no, it's a
It's so easy. It is a pattern. It is a pattern. You must like patterns. Do you like patterns? Ah. Nice. All right. We doing okay? Wait, how many numbers do you have? 1, 2, 3, 4, 5? No. No. Okay, 4th floor, 4. What's P? P is always a 1. And then what bedroom are we talking about?
4.
Yeah. Which bedroom do you want? Which orbital do you want in the P subshell?
Oh, -1.
-1. That's all there is. I'm not sure why we were having extra numbers.
I thought we need to write whole.
No, because that only makes one orbital.
Okay.
That is only 1.
So
Okay?
this would be like 4, 1, and 0.
Yes. Yes. Okay, so we doing all right? Does everybody think we got that one? Okay, so this is 4. Is that P? This is P.
Yeah.
What's the number for P? What's the number for P? 1. Okay, what's the number for S? 0. So I'm talking about 4P, so it has to be 4-1. It's not going to be 4-0, right? Okay. Okay, does this look like your numbers? What do you think? Has everybody got this one? You see how we're talking 6s? So that would be 6. S is always 0, and the orbital is 0. So it's 6, 0, 0. Okay, well, let's do 4. 4p. Well, here's 4p. 4, 1, and then I could be in this one, 4, 1, -1. Or I could be 4, 1, 0, or we could be 4, 1, +1. Okay, can you see that? So is this what we have for our numbers? Yeah? Everybody got that? Okay, so you know where all the electrons are in this. You know how the apartments are arranged in our apartment building, right? We know this is your quantum model. This is how the electrons are arranged in these orbitals. Okay, we have the s orbital, we have the p orbital, we have the d orbital, and the f orbital. These orbitals are like the bedrooms we were talking about. Okay, they're orbitals in a shell. That's like, bedrooms in an apartment, subshell, shell. Okay, so you have orbitals in a subshell, and they're on shells. Okay, so this is our apartment building, or our quantum model, how it's all arranged. And we can send mail to any of those electrons, or in other words, we can pinpoint every single electron by specifying the quantum numbers. If I said these quantum numbers, 600, could you tell me which orbital the electron was in? Yeah, you could, couldn't you? That's right. Okay, so that's how it works. Well, in this apartment building, or in our quantum model, there's different numbers of electrons on every shell. Okay, so the fire chief comes along and he says to the apartment owner, hey, how am I supposed to know how many electrons are on each shell, because you got different numbers of electrons on every shell. In case there's a fire, I got to make sure everybody gets out, so how am I going to know that? So the apartment owner's like, yeah, you're right, it does vary every floor, does change with the number of electrons. So he decides to tell the fire chief, he says, I'm going to give you a formula. It's 2n squared. N referring to the shell. So it's a good thing the fire chief knows his algebra, because now he can figure it out. If he's on shell 1, how many electrons are on that floor? 2, right? 1 squared times 2. So 2 times 1 squared is 2. So there's 2 electrons on the first shell. Well, what about the second shell? Well, that would be 2 times 2 squared. So what is that? 2 times 2 is 4 times 2. Yep, there's 8 electrons on the second shell. Now, what about the third shell? Okay, 2, 3 squared. How much is that? 9 times 2, 18. So it keeps increasing for every shell. We get more and more electrons on every shell. And you can see that here. So on the fourth shell, we're going to have 32. Okay, and you can see how they're arranged. There's 2 in the S, 6 in the P, 10 in the D, and so forth. Okay. Yeah, if you go more than 32, yeah, let's talk about shell 5. Okay, so it keeps going up, right? Okay.
We have like element or not? We have like element or not?
Well, no. You'll have some elements in the S and the P, but not like, for example, 6F or 6G, or there just isn't. So only on the upper floors are you going to have some before we've run out of elements. Okay, so we talked about how the orbitals get bigger for every floor, right? 1s is, and then 2s is bigger, 3s is bigger, 4s is bigger. So they keep getting bigger as we go. Now, if you cut open that, what does it look like? The bigger we are, the more we have these areas of probability that are white right here. So what that means is it's a node. What's a node? It's an area where the electron cannot be. It's an area of probability where the electron is not going to be. So if you're looking at the 1s orbital, do you see where the area of probability is? Yeah, it's in the center. It's like a sphere, right? Well, what about the 2s? Well, we have some in the center, then you have a node, and then you have some around here on the outside. So the bigger we go, the more nodes we're going to have. So you can think of a node as like a wall. You can't live in a wall. So it's going to be here or it's going to be there. So the bigger we are, the more nodes we have with these areas of probability. Okay, so we've already talked about those. Now, when we talk about atoms, we always represent them as a ball. Why are we representing them as a ball? Well, because all of these S, P, D, F subshells, all of the orbitals, all of those are just laid right on top of each other with the nucleus in the center, and all of them are stacked on top of each other. So can you see the S orbitals? It's a blue big S one, and then can you see maybe some P? You see the orange P ones in here? Can you see the orange P ones? There's 3 of them, remember? Yeah. So you got 3. Can you see them? Orange, there's another one. There's another one. So those are the p orbitals. And then layered on top of that would be the d orbitals. Do you see the yellow d orbitals? Yeah, you see, there's 5 of them, so it's kind of hard to see all of them, but they're going to be layered in there. So that's how come we talk about atoms represented as a ball, because all these orbitals just lay right on one on top of the other. That's why we need to have all that space. So we talked about our stadium with the nucleus being small marble, and then the whole rest of the stadium is the rest of it. We've got all these orbitals, and they keep getting bigger as we go. So all that space are the areas of probability of where the electron will be. Now, we also said the energy keeps going up. Well, why does it keep going up? What's that got to do with it? Well, the closer you are to the nucleus, the lower the energy. So if you're looking at 1s as kind of small, they're fairly close to the nucleus, aren't they? That's going to be low energy. Well, didn't we say 2s was a little higher energy? Okay, so here's 2s. Most of them are further from the nucleus. It's a bigger orbital. But we got that little bit in the center there, and you had the node. So still a little farther. And then here, farther still. So the farther you are away from the nucleus, the higher the energy, exactly. The closer you are to the nucleus, the lower the energy. Okay, the farther you are from the nucleus, the higher the energy. Now, don't forget, though, we have these little node sections where part of it is close to the nucleus. So, if we're talking about our order of energy, let's see if you can tell me what is what. All right, so there's 1s. That's very close to the nucleus, right? So that's the lowest energy. Now look at the other two, 2s and 2p. Which one looks closer to the nucleus? It kind of does, but don't forget this little piece right here. That's very close to the nucleus. So because of that little p, 2s is actually lower energy than the 2p. So that's why it starts to get a little bit more complicated, because of these little pieces that come in closer to the nucleus. And as the further we go, you see how it's starting to get more complicated?
Yeah.
That's why the order of energy is not really a smooth, straight, 2s, 3s, or 3s, 3p, 3d. It's why it starts to change a little bit as we get further up, because of this penetration. Now, as you go further into the nucleus, we'll talk about shielding effect, and we'll talk more about that in Chapter 7, but just to mention that, is that an electron on the outer skirts of the atom, this electron does not feel the same pull as these electrons close to the nucleus. They all don't feel a +3. It's not all the same for every electron. For example, if I have this heater here, and it's a really cold day, it's kind of getting cold out there today. It's a cold day, and the first group of people around the heater, ooh, wow, can they really feel the heat, right? It's like, oh, it feels so good. Well, that's the first group of people. But what about if we had another group of people behind them? Not as much as the first people. And if you go further out, yeah, pretty soon you get so far out that you're like, what heater? I don't feel anything. I'm leaving. So the outer electrons are the ones that come and go because of that difference of the shielding effect. Okay, so we'll talk more about that when we get into Chapter 7, which will explain some of our periodic trends. So this is why the order of energy goes the way it goes, and that's why it starts to change a little bit up near the top, because we've talked about who's closer to the nucleus and that little bit of part that comes close to the nucleus. Okay, so here's your order of energy. All right, so we've got the model, we got the quantum numbers. Now let's talk about moving into the apartment building. Okay, so here comes the electrons, all their little suitcases, and they're going to figure out where are they going to go and get their little apartment, where are they going to live. So this apartment owner, he's very particular. He only wants to fill these orbitals, in this case they're boxes, he only wants to fill them in order of energy. This is called the Aufbau principle. We do need to know the name of that to be able to say, oh yes, the Aufbau this principle. Aufbau, anybody speak German? I think it means building up, German for building up. So the lowest energy gets filled first, and that's Aufbau. So if you're going to rent some, you're going to rent your apartments out to these electrons, which one are you going to rent out first? The lowest, which is 1s. Now, it has to be completely full. Do you remember how many electrons we can put in here? 2. So you have to fill this up with 2 electrons before we can go to the next energy level. So you have to fill them in order of energy. So once this is full, then we go to this one. How many electrons do you have to put here? 2. Then you go to this one. How many electrons do you put here? 6. I got to put all 6 of them in there before we can go to this one. Okay, so how many do I have to fill here? 2, and then I can go to the 3p. And how many do I have to have here? 6. When that's completely full, then I can go to the next one. So you see how we go in order of energy? Okay, so we have to go in this order.
Why 3D came faster than 4P?
Because of what we were talking about with that dipping closer to the nucleus. That's what causes that shifting. Okay, so that's why the order of energy is like that. All right? So we have to fill this completely in that order of energy. So it's important for us to know the order of energy. And we'll talk more about how we're going to do that. Okay.